We're going to start with f, and like I said, I'll make videos of the other ones that are a little bit less interesting. This is the most interesting. The first thing I need to do is I need to put it in the correct form. The form that we have for any of our sine and cosine functions is f of x is equal to a, and then my function, well, this is cosine, so cosine. And then it is, I believe it's omega. What is it, omega? Yep, omega. So then it is omega. My angle minus phi. I'm going to use alpha because I have a hard time writing phi correctly. And then plus, they call it b, is your movement up. So the first thing I notice is that I have a coefficient on that x, which is my angle, which means the first thing I have to do is factor that out. Before I even talk about the transformations, I have to have it in the correct form. So I'm going to rewrite this as -1/2 the cosine of, and now I'm going to factor a 3 out of both of those. So when I'm factoring, what I'm undoing is multiplication. So if I'm doing multiplication, then what I'm doing is dividing each piece by that 3. So it is 3, and then it's x minus. When I take 1/2 and divide it by 3, it's the same thing as multiplying by 1/3. So it is pi divided by 6. Now I can actually talk about the phase shift correctly. Until then, until I make that coefficient on my angle to be 1, I can't talk about the phase shift. I can always talk about what the period is based on what that coefficient on the angle is. Now my angle is x. Could have been theta, but it's x. So the first thing I'm going to do is this one here. This takes and reduces my period from 2 pi to 2 pi divided by omega, which in this case is 2 pi divided by 3. Okay? So instead of having from 0 to 2 pi to complete the cycle, it is going to go from 0 to 2 pi over 3 without a phase shift. Let's start putting my key points for cosine. My first key point is 0, 1. My second key point is pi over 2, 0. My third key point is pi -1. And my fourth key point is 3 pi over 2, 3 pi over 2, 0, and then back to 2 pi, 1. Those are my key points. And as I said before, I always do this part first. What that does is it takes all of my x's and I divide by 3, just like we learned in pre-calc 1. So I'm going to take all of my x values in my key points, and I'm dividing it by 3. So my x values, not omega, my x values divided by 3. So all of my key points, right now, I have 1, 0, -1, 0, and 1. I have not changed any of my y values, so I just write those down exactly the way they are. Yes?
I just have a question. You have the negative, initially you have -5 over 2. How do you get -5 over 6 from that?
So the question is, how did I get this pi over 6? Is because I'm taking, let me move up here. I am taking this pi over 2, and I'm factoring out a 3, which means I am undoing multiplication, which means I am actually dividing by 3, in other words, multiplying by 1/3. Yes?
What's the 2 pi divided by w part?
That is my period change. So my period change, my omega is this value. The coefficient on x is my omega. If I don't see anything there, that means my period hasn't changed in terms of the length of the period, but it may move left or right if I have a phase shift. Okay, so I'm going to go back over here, and I'm going to take all of my x's, and they're all going to be divided by 3. Well, 0 divided by 3 is still just 0. When I'm dividing by 3, it is the same thing as multiplying by 1/3. So when I multiply pi over 2 by 1/3, I'm going to get pi over 6. Multiply pi by 1/3, I get pi over 3. Multiply 3 pi over 2 by 1/3, I get pi over 2. And multiply pi over 2 by 1/3, I get 2 pi over 3. So I have done my period change in all of my key points. The next thing I'm going to do on all of my key points is I'm going to deal with, I'm going to erase this, give me a moment to erase this. I'm going to erase this. I'm now going to deal with my, erase this too. I'm now going to deal with my phase shift. So my second thing I do, if I have a phase shift, I do my phase shift. Now it's inside of my function. So it's going to do the opposite of what I want it to do. I want to be able to subtract, but I'm going to be adding pi 6 to all of those values I found on my x's. So I'm going to take all of my x values and I'm going to add pi over 6. This is my phase shift. I'm picking up my cosine wave and I am moving it to the right pi 6. So again, you will notice that I write down all of my y values because I'm not working with them right now. They're just coming along for the ride for right now. And I'm going to add pi 6 to the first one. So 0 plus pi 6 is pi 6. Pi 6 plus pi 6 gives me 2 pi over 6, which is pi over 3. Now I got to do some fractional work. So here, pi over 3 is the same thing as 2 pi over 6, and then I'm going to add pi over 6. That gives me 3 pi over 6, which reduces to pi over 2. I'm going to take my pi over 2, common denominator here is 6, so I'm going to make this as, not that, we're going to make this as 3 pi over 6, and I'm going to add to it pi over 6, which is 5 pi, or 4 pi over 6, which reduces to 2 pi over 3. Watch my math, because, you know, I have problems with fractions too. Are you okay so far? Okay, cool. I'm going to take this one, and again, I need to have common denominator. So the common denominator is 6. So 2 pi becomes 4 pi over 6. Plus pi 6 gives me 5 pi over 6. So my last 5 pi over 6. All right? How are we doing? I have completed what's inside of my domain. I've changed my period and I've done my phase shift. Now it's time to go outside of my domain. So now I'm going to start messing with the range. I'm going to start messing with my y values. So as I come back over to my original equation here, this is going to take and multiply all my y's by exactly what I see. When it's outside of my function, it does exactly what I want it to do. Now those of you who have had me in pre-calc 1 know my story when I talk about inside and outside. So when you go to adopt a pet, right, or if you're in a relationship, so those of you who don't have relationships yet, that's cool. That's cool, actually. Envy that. I love my husband. I just want to say that. Especially how the things, Valentine's Day is coming up. I love my husband. I want to say that now. Because he might watch this. Anyways, when you are in a brand new relationship and that person is not living with you, right? It does exactly what you want it to do. They will call you, they will take you to dinner, they'll pick up their clothes, they'll pick up their socks, and they won't leave their shoes throughout your damn house, everywhere so you can trip over them, right? Because they're not living with you. They want to live with you, but they're not living with you, so they're going to do exactly what you want them to do. The moment they live with you, they do the exact opposite of what you want them to do. So once it comes into your function, which is all of these, it does the exact opposite. Notice I did not multiply my x's by 3, I divided by 3. Notice I did not subtract off pi over 2 or pi over 6, I added pi over 6. If it is not in your house, it does exactly what you want. It messes with your range and it does exactly what you want it to do. If it's inside your house, inside of your function, it is messing with your domain and it does the exact opposite of what you want. Not that I have any experience with that at all. I love my husband. Let's keep moving. So that negative 1/2 is outside of my function, so it is going to take all of my y values and multiply by negative 1/2. So I have all of my y's will be multiplied by negative 1/2. Notice when I do this that all of my x's now is what I write in black because they are stable. Those have stabilized. I multiply all of my y's by the negative 1/2. When I multiply all my y's by negative 1/2, I get negative 1/2 for the first one. And then I get 0, and then I get positive 1/2, and then I get 0, and then I get negative 1/2. Now that I have all of my key points, I can graph this. So I don't have any movement up or down, so I am going to be on the x-axis. My starting point is pi over 6. My ending point is 5 pi over 6. So again, here's my starting, here's my ending. I'm only doing one cycle. My halfway mark is the pi over 2. The quarter mark is pi over 3. The 3/4 mark is 5 pi over 6. I'm getting that all from my ordered pairs, but doing it by the key points. My first ordered pair gives me pi over 6 negative 1/2. So I'm going to start right here. My next ordered pair is pi over 3, 0. That's that one right there. My next one is pi over 2, 1/2. That's that one there. My next one is 3 pi over 2, 0. That's that one. And then my last one is 5 pi over 6, negative 1/2. So here is my transformation of my cosine wave. Oh, thank you. I'm sketchy. Thanks for paying attention to that. I am sketchy. Sketchiness today. Yeah, I'm from Longview. What do you expect? Actually, I'm not from Longview. I just live there right now. Yeah, I'm just saying I just live there right now. It's my temporary housing situation. After you get out of Longview. And you get past that smell of the pulp mill. You got to get out of Longview, though, like a ways. No offense to anyone who loves Longview. Washington, we're not talking about Texas. Okay, cool? Are we cool? We cool? All right. I will do the other ones. Okay, so let's just talk a little bit about this, about how we would write these. So with your partners, take a moment to do, I want you to do B, please. So take a moment to do B. Write on your paper what you would write for B if that was on the test. Give you a moment to do that. All right, so B, let's talk about what each piece does. So the down 2 units, if I look at this is a cosine. So if my function f of x is equal to a cosine omega x minus, I'm going to call it theta instead of phi, and then plus b, what is that down 2 units? Which part is that? That is the b part. So this is b. And I have pi over 3 to the right. Which part is that? So this is my theta. And then horizontally stretched by a factor of 4. Which one is that? That is my omega. So let's bring this all together. So this is going to be equal to, I'm just going to write it down here. My y is equal to, do I have any kind of a value I have to worry about other than 1? No. So it is going to be the cosine of my omega. Do I put 4 or do I put 1/4? 1/4. Because it's always the opposite. Because it's a stretch, it needs to be a fraction less than 1. And then x. I'm going to the right, so is it a plus or minus? And there it is in all of its glory. Oh, thank you. Sketchy this morning. Sketchy. I live in Longview. I'm sketchy. All right, how are we doing?
So are you selling your house, right?
I hope so.
Okay, so where are you planning? Where are you moving after? Like, what city do you want to live in next?
Centralia is much better.
Yeah, you think it's Centralia? Okay.
Yeah, I'm actually thinking about Centralia. What is it? That hill over there is supposed to be really nice.
Yeah, that's quite sure.
Yeah, either that or there's some land that way.
My buddy used to live in a house up there on that hill, and it was like this ridiculously nice. Go balcony, went around. Oh yeah, you got some nice houses up there.
Okay, so let's just talk about this example here where we actually use a sine or cosine wave. So there's applications to this. Those of you who are going to be engineers, you're stuck with it. I mean, you're going to have the joy of using this the rest of your lives. Those of you who are not engineers, you may or may not see this, but if you're going to the medical field, you will. You'll see sine and cosine waves in the medical field. So we have a weight hanging for a spring with an output velocity of 4 centimeters per second. A formula that gives the location of the weight in centimeters as a function of time t is given by this. Find the period of the function and sketch its graph from pi, or from t, in the interval from 0 to 4. Now what do you notice about this interval that we haven't seen before? It's not in pi, right? It's not in pi. So that would probably imply that my period will not be in terms of pi. And I know it's going to happen because my omega is pi. My period, for any of these, my period is going to be equal to, in this case, it's cosine, so it is 2 pi divided by omega. 2 pi divided by omega. Well, what is my omega in this example? Pi. So this is going to be 2 pi divided by pi, so my period is 2. So when I go to sketch this graph, there's not going to have any pi's on it. It's going to have 0, 1, 2, 3, 4 on up. That makes my life easy. So my sine, because I have no transformation left or right, I'm going to start at 0, I'm going to end at 2. My halfway mark is what?
1.
What is my quarter mark? 1/2. Isn't this nice? What is my 3/4 mark? 1.5. It's all good. So then all I have to do is talk about what this is doing to it. What is that negative pi over 4 doing to it? What is the negative doing to it, first of all? We're doing a reflection across the x-axis. So, and instead of going from -1 to 1, what am I going to go to? Negative pi over 4 to pi over 4. That's my amplitude. So I'm going to come over here, and I know that this thing is going to max out at 4 over pi, and we're going to have a minimum of -4 over pi. Then all I have to do is, normally this is what the sine wave looks like. The sine wave should look like this. That's what it should look like. Because I have the negative, I'm going to go into a minimum first. So it's going to go like this. And I'm just going to replicate that for a second cycle, because they want 2 cycles, because they want it from 0 to 4. How was that? Not too bad. Not too bad. If I asked you, where is this thing neither increasing or decreasing, where would you tell me that is? At what time does that happen? Where I'm neither increasing nor decreasing. So this is bringing in some of the stuff from pre-calc 1. So I'm decreasing from 0 to 1/2, but where am I neither increasing nor decreasing? What am I asking for? What am they asking for? I'm asking for the minimum and the maximum. So even though we're not directly asking it and teaching it in this course, we may ask questions from it because we learned it in the last course. So if I asked you, where is this at, where it's neither increasing or decreasing, you would tell me at t equals 1/2. You would tell me at t equals 1.5, and all the rest of them in that area, because that is a maxima or a minima. The intervals of increasing would be from 1/2 to 1.5, but that maxima or minima, we are neither increasing nor decreasing. So that is a question that could come up. All right. Here is my secant. When you are drawing the secant, your best bet is to draw the cosine wave. Notice here you're going to see the cosine wave. here is the cosine wave. When I'm asked to draw the secant, I actually draw the cosine wave first. What I know is that secant and cosine have the exact same answers in 3 places. Wherever my cosine is 0, my secant has a vertical asymptote. So my cosine has a 0 right here, which produces a vertical asymptote because these are reciprocals of each other. Wherever it has a 0 here, it is a vertical asymptote. The fundamental cycle goes from 0 to 2 pi. So it is the same fundamental cycle for 0 to 2 pi as it is for cosine. And cosine and secant have the exact same outputs in 3 places. So these have 3 key points, not 5. It only has 3 key points, but it does have 2 vertical asymptotes. So we have to do the transformations on the vertical asymptotes as well as those 3 key points. So I'm just going to go here. So there are no x-intercepts. There is one y-intercept. That's one of the key points. We have those 3 key points on the fundamental cycle, and we have 2 vertical asymptotes on the fundamental cycle. Give you a moment to write those down. Cosecant. Again, when I do the cosecant, I draw my sine wave. So first thing I do is draw my sine wave. And then from my sine wave, wherever my sine and cosine are the exact same, in this case is pi over 2 and 3 pi over 2. So this only has 2 key points, and it has 3 vertical asymptotes. So don't panic if you're still writing, because I'm just going to move it here so you can actually see it. So this has 2 key points. This only has 2 key points, which is at pi over 2, 1, 3 pi over 2, negative 1. It has no x or y intercepts without transformations. My vertical asymptotes are at 0, pi, and 2 pi. So my vertical asymptotes are in multiples of pi. Because wherever sine is 0, my cosecant will have a vertical asymptote. Because it's undefined, because they are reciprocals. So I'll give you a moment to write that down. And why is it shaped like that? Well, the sine of theta is equal to 1 over the cosecant of theta. Or we can write this as the cosecant of theta is equal to 1 over the sine of theta. So all of these are going to be reciprocals, right? So if my sine, if I'm doing the 1 over the sine of pi over 4, the sine of pi over 4 is 1 over the square root of 2. So that means my cosecant of pi over 4 is going to be the square root of 2, because they are reciprocal buddies. So as sine gets closer to 0 here, the reciprocal of something very small is very large. So as sine gets to be a smaller and smaller number, the reciprocal of a smaller number is a larger number. So as sine goes to 0, my graph goes up. And that's why it has that shape. At this point and this point, because sine is 1 or negative 1, the reciprocal of 1 or negative 1 is 1. And so that's why it has that shape, because they're reciprocal buddies. Does that answer your question? Okay. So this is just wrapping up what we just talked about. The domain of our function for our secant is everything but pi over 2 and then shifting over pi, multiples of pi. So secant does not have, in their domain, it does not have pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and also going in reverse without transformations. The range goes from negative infinity to negative 1, and then jumps from 1 to infinity. So that's what this notation is saying, is From negative, and it goes from negative infinity to negative 1, and then it jumps from 1 to infinity. So there's a span in our range that you are missing. There's a place in it where you have no values for my outputs. On its domain, it's smooth and continuous. This is going to be important in calculus. It is an even function because its reciprocal, which is cosine, is even. And it also has period 2 pi. Because they are reciprocals of sine and cosine, both secant and cosecant have periods of 2 pi. The cosecant is similar. Its range is similar. There's a place in my y-axis in which I don't have any values. So that's what this is saying here. Again, I'm going from negative infinity to negative 1, and then 1 to infinity without transformations. Because cosecant is the buddy of sine, then it's going to have vertical asymptotes wherever sine is 0, so that's multiples of pi. Pi, negative 500 pi, positive 500 pi, 3,000 pi. All of those are where we're going to have vertical asymptotes without transformations. It is odd because of the function that is the reciprocal is odd. And it also had period 2 pi because it is the reciprocal of a function that has period 2 pi. Any questions? I'll give you a few moments to write all that down. All right, let's keep moving. I'm going to go back to graph these in a moment. We are going to graph these in a moment. Now we're going to do tangent and cotangent. Like I said, we're going to go back and graph those in a moment. So my tangent here, if my input is negative pi thirds, my output is negative square root of 3. So clearly that is not going to be my key point, because I don't know where the square root of 3 is. Well, I have negative pi fourths is negative 1. Negative pi over 6, again, is negative square root of 3 over 3. And I'm not going to use that as a key point. 0, 0, I know how to graph that. Pi over 6 gives me square root of 3 over 3. Not going to graph that well, so it's not going to be a key point. Pi over 4, I can. Pi over 4 is 1, so that's a key point. Then pi over 3 is one that is not a nice key point. So this is what the tangent looks like. Now notice, this is the first time we start using negative angles. Up until now, our period has gone from 0 to 2 pi. The reason I use negative angles is because this is what the tangent looks like. The tangent has vertical asymptotes at pi half, and negative pi half, and 3 pi over 2, and 5 pi over 2. And that's because I am dividing by cosine. So wherever cosine is 0 is where my vertical asymptotes are for my tangent. So this actually doesn't look like a wave. Looks more almost like a cubic function. Almost like a cubic function. But it's not. It's the tangent. So the tangent here, so what it looks like, see how it has multiple ones. The fundamental cycle is the blue one. My key points are negative pi over 4, comma negative 1, 0, 0, pi fourth, comma 1. Those are my key points. I have 3 key points. My total length of my period is pi. So I go from negative pi halves to positive pi halves because that length is pi, but I don't start at 0 this time. I do not start at 0. The vertical asymptotes are at positive and negative pi over 2. So negative pi over 2 and positive pi over 2. And that's because where cosine is 0. They're multiples of pi over 2. Let you all have a chance to write that down. So cotangent is the reciprocal. That means wherever sine is 0 is where I have the vertical asymptotes. Notice that where the cosecant has vertical asymptotes is where my cotangent has vertical asymptotes, because sine is in the denominator. So my vertical asymptotes on these are at multiples of pi. So pi, 2 pi, 3 pi, 5 pi, negative 1,000 pi, positive 50 pi. So wherever sine is 0 is where I'm going to have vertical asymptotes, because cotangent is defined as cosine over sine. It also will have 3 key points, and those are the 45s in the correct quadrants. So my key points are pi over 4, 1, pi over 2, 0, 3 pi over 4, negative 1. My vertical asymptotes, again, are in multiples of pi, so 0 and pi on the fundamental cycle. Both tangent and cotangent only take a period of pi. So when we talk about period, it is where we start and where we end for the fundamental cycle. It does not mean I'm always going to start at 0. Tangent does not start at 0. But if I go from negative pi halves to pi halves, the distance I traveled is pi, that is my period. So I don't have to start at 0. The period is how far you travel from beginning to end of your cycle. It doesn't have to start at 0. How are we doing? Doing cool? Cool? All right. So here are the properties of tangent and cotangent. My range of both of those are the only ones that have negative infinity to infinity. Of all of my trig functions, the only ones that have range from negative infinity to infinity is my tangent and my cotangent. My domain is restricted where I have vertical asymptotes. My domain is similar to, on tangent, is similar to the domain on the secant, because cosine is in the denominator. So the domain of my tangent is similar to the domain of my secant function. The domain of my cotangent is similar to the domain of my cosecant, because sine is in the denominator. These do not have amplitude because I have no maxima or minima. I don't have absolute or relative. These are both odd. We have symmetry with respect to the origin. They're both odd functions. They're both smooth and continuous on their domain, which is important in calculus. Yes?
Is that the only reason? Because I was just, on all of them, they all said smooth and continuous. Is it just for calculus?
Yeah, so when you all get into Calc 1 next quarter, then it's really important that it's a smooth, continuous curve, or you can't do the derivative of it. So it has to be a smooth and continuous curve on its domain.
I didn't know if it would have any effect on what you're doing.
Not right now, no, except for just to remind yourself that it should be smooth looking. So don't make, what it should do is if you're doing the sine wave as an example, don't do this. That's not a sine wave. It's some weird absolute value stuff going on. So make it nice and curvy. It's so pretty. Okay? How are we doing? How many of you all gone on to calculus? Let's assume we're all passing. Let's assume we're all passing. All right. I'll pause this for a minute. Let's do D, but let's make D more interesting. We've got to make this more interesting. So on D, let's throw in something, say, I don't know, -3. Let's put in a -3 here because it makes it more interesting. So let's write this as y equals -3, the cosecant of pi over 2x plus pi over 2 minus 2. I need this to look like this. I need it to be y equals a, the cosecant of omega, x minus theta plus b. Is it in that form? No, it is not. So I have to make it in that form by factoring out what? Pi over 2. So this is going to be y equals -3, the cosecant pi over 2, and then x plus what? 1. All right, the first thing I do is my period change. This is omega. So my period is equal to, because this is a reciprocal buddy of sine, my period is going to be 2 pi divided by omega. So this is going to be 2 pi divided by pi over 2. Because it's a division of fractions, this is going to be 2 pi over 1 multiplied by 2 over pi. Because it is the reciprocal of my denominator fraction. What happens to my pi's? Sweet, that is so nice. You know why that's nice? Because when I do my x-axis, it's just going to be nice integers. Possibly some fractions thrown in there, but it's going to be integers. So the first thing I'm going to do is think about the sine. So I actually do the key points on sine. So my key points on sine start out with 0, 0. And the next one is pi over 2, 1. Then pi, 0. 3 pi over 2, negative 1. And 2 pi, 0. On my cosecant wave, right here, here, and here are my vertical asymptotes. But I still do the key points for sine. So the first thing I'm going to do is my period change, which is that part. So I take all of my x's, and I'm going to divide by pi over 2, which is the same thing as multiplying by 2 over pi. Right now, my y's are stabilized, so I'm going to write those down first. And I'm going to multiply all of my x's by 2 over pi. When I multiply my first x by 2 over pi, I still just get 0. When I multiply my second one by 2 over pi, I get 1. My next one will be 2. We're liking this, aren't we? The next one is 3. And the last one is 4. No fractions, baby. That makes us so happy. All right, coming back here. What does this, if I can get back over here. This is a plus 1, so what am I going to do to all my x's? Subtract 1. So I'm going to take all my x's and I'm going to subtract 1. So x minus 1. So my y's are still stable. And I'm going to subtract x's from all, I'm going to subtract 1 from all my x's. So negative 1, 0, 1, 2, and 3. Isn't this sweet? We're digging this. Now, I have to go back to this, and it's telling me I need to take all of my y's and multiply by negative 3. I'm outside of my function now, so I'm doing all of my y's. My x's have stabilized. So negative 1, 0, 1, 2, and 3. Those have all stabilized. I'm going to take all of my y's and multiply by negative 3. So my first one is still 0. My second one is going to be negative 3. My third one is 0. My fourth one becomes positive 3. And my last one is 0. How are we doing? We love it when we see this. Nice integer numbers. We're digging this. So thank you for picking this one. The last thing I'm going to do is take all my y's and subtract 2. So again, my x's are stable. I'm going to take all my y's. Was it subtract 2? I want to go back. Is it subtract 2? Yes. Okay, so I'm going to take all my y's and subtract 2. So it's going to be -2, -5, -2, help me out, 1. Is that right? Yeah, I'm sketchy. You got to help me out here. And then -2. Now remember, going back to the very beginning, this represents where my vertical asymptote is. This represents where my vertical asymptote is. And this represents where my vertical asymptote is. Those three places are where my vertical asymptote has moved to. So on my graph, so these are vertical asymptotes. On my graph, I know that I need, starting with -1, then I need 0, then 1, then 2, then 3. I have my first vertical asymptote at -1. I have my next vertical asymptote at 1. I have my last vertical asymptote at 3. Those are the x part of those ordered pairs. So this gives me a vertical asymptote at x equals 3. This gives me one at 1, and this gives me one at -1. Does that make sense? I'm going to draw the cosine or the sine wave so you can see where the sine wave would have been. The sine wave would have been moved down 2. So the sine wave would have been right here, moved down 2. The sine wave would have been reflected over the x-axis, moved down 2, and stretched. So my sine wave would have had these key points, which is -1, -2. The next key point would have been here for the sine wave, which is right here, which is the 0, -5. My sine wave would have been right here, which is the 1, -2. My sine wave then would have been up here at 2, 1. And my sine wave would have been down again at -2, 3. So this is what my sine wave would have looked like. But I'm not graphing the sine wave. What am I graphing? The cosecant. So in black, here is the transformed cosecant in all of its glory, with the key points and with the vertical asymptotes. Notice that I did it with the sine wave, though. You do it with the sine wave or the cosine wave, and then you draw the graph from the sine or cosine wave. Have a great day. We have finished 10.5.